The case now we are discussing the concept of critical velocity. The concept of critical velocity. So let us consider the concept of critical velocity. Here, so we have taken a spherical body. So the spherical body having a density sigma. Its radius, of course, is r value. It is falling through a medium having density rho. So this is an air medium. Let us imagine this is what medium it is. Air medium, it is there. So in this air medium is falling through. So now what is the gravitational force acting on this? Fg. What is the formula for Fg? Fg equal to m into g, where m is what now? Mass of the body. So I can replace mass by what now? Density into volume of the body into g. That's equal to density into volume of the body. How much it is? 4 by 3 pi r cube into g. That is force due to because of gravity. At the same time, what will happen here? There is a force acting in one direction, upward direction. Because of what reason? Because of buoyancy. So let us see that force acting in one direction, upward direction. Because of what is? Because of buoyancy. That is what we call force of buoyancy. Along with that, there is a force which is acting. In what direction it is acting? One more force acting in one direction, upward direction. Upward direction it is acting. That is because of what now? Viscosity of the medium. So if I take this F viscosity equal to 6 by eta RV, this is called Stokes law, Stokes theorem, as per Stokes law. Now, force of buoyancy is given what formula again? Mass of the liquid displaced divided by multiplied by g. Here m stands for what now? M stands for mass of the liquid displaced. Mass of liquid displaced. Now this mass of liquid displaced, I can write m equal to density of liquid into volume. Let us assume rho is the density of what? Of liquid. So now volume is same now. So 4 by 3 pi r cube. Now, as we insert here, force of buoyancy become what now? Rho into 4 by 3 pi r cube into g, that is force of buoyancy. Now, after traveling through certain distance in a liquid medium or in what now? Air medium or any viscous medium, the body achieve constant velocity. So, constant velocity means acceleration become what now? Zero. If acceleration become what? Zero, net force become what now? Zero. As the net force becomes zero, total upward force, that is F due to buoyancy plus F due to velocity viscosity, must be equal to F due to what now? Gravitational force. Now let us insert these values now. Force of buoyancy, how much we found already? M into G. M is this value already there. So density into 4 by 3 pi r cube into what is G plus force of viscosity 6 by eta RV, that's equal to rho in sigma into 4 by 3 pi r cube into g. Now let us simplify this one. So if I take this value here, 6 pi, yeah, if I take the value here, no, 6 pi eta RV, that's equal to, now what is common there? 4 by 3 pi r cube into, this become what now? sigma minus here look at now. R equal to capital R. Simply I took different, so it's same thing it is now. So if I take 6 pi eta RV, that is equal to 4 by 3 pi R cube into G is missing here. That is sigma minus rho into G it is. Now what is going to cancel? This is cancelled. This will become 3 times. This will become 2 times. So 3 will come down here. Okay, let us go a little bit down. Yeah. Yes. Yeah. So now if I take this one, it will become what now? Pi, pi completely cancelled. So ADS is one time cancelled. Then velocity V equal to, it will become 2 by 3 into 3, it is 9. So remaining part is what now? R is cancelled one time. Remaining what now? R square by G, not G. So G will not be there here. R square by what is? R square by, yeah, r square by 1 time is cancelled. So remaining eta will come down here and multiplied by sigma minus rho into G. So this is a formula called, okay, this formula is what we call the concept of what is terminal velocity. Now, if I take this formula again further on, now look at how does V depends on? V depends on R square. Remember this case carefully. One case. Next further case if I go on, how does it depends on remaining factors? Let's see now. Okay, so let's see now one thing. Then velocity. Now look at this mass. How does mass depends on m proportional to r cube? That is a one more case. Now if these two cases, then let us take linear momentum p equal to mass time of velocity. So p proportional to mass is what now? R cube. Velocity is how much it is? R square. So p proportional to r to the power of 5. So this p stands for here linear momentum. Linear momentum. This is what we call terminal velocity. Terminal velocity. Okay, this is what we call mass. And this R is what we call the radius of the body. The radius of the body. Now look at this, how it depends on, okay. Now if I take kinetic energy, what is the formula of kinetic energy? Half mv square. So kinetic energy proportional to mv square. So kinetic energy proportional, how does m depends on r cube. So v depends on r square. Whole power how much it is square. So kinetic energy proportional to r to the power of 3. This is r to the power of 4. So kinetic energy is proportional to r to the power of 7. So this is it depends on kinetic energy. So three factors you have learned here. Depends on kinetic energy. This is called kinetic energy. Kinetic energy. So, kinetic energy, momentum, mass, velocity, all the cases. So, this case is very important. This case is when the body moving with terminal velocity. So, acceleration is zero. If acceleration is zero, what's the meaning of that? The net force acting must be equal to zero. That's the case of terminal velocity, how it depends on. Now, if you look at the different cases of question based on this, you need to find out and solve it. Okay. Yes.